Welcome back to Nomenclature. I have changed both the molecules that I said I was going to continue with so that I could deal with the double switch method next. This is not a stereocenter. It has two iodines on it. This is a stereocenter. It has an isobutyl group up here, a 1-iodo-propyl group here. It has two CH2s followed by a C with two I's, and then it has two CH2s followed by a C that doesn't have two I's. That's four different groups. The carbon with the iodine has priority number 1. The CH2 that hits a branched C is going to beat the CH2 that hits a C with only one bond to C. Similarly, the CH2 that hits the branched C is going to beat the CH2 that hits the CH2 that has only one more bond to C. Notice we broke the tie much earlier than reaching the iodines. I'm going to move a little quickly now. I'm assuming you've had a lot of practice and are getting to the point where you can do this or get a little closer to this. Is the number 4 group on a dash? The answer is no. We need to follow the double switch method. Step 1, I'm going to copy the tetrahedron exactly the way it is drawn. I do not need the groups attached, I just need the bonds in the tetrahedron. Switch the number 4 group with whatever is on the dash. The 1 is on the dash, the 4 is here. 4 needs to be on the dash. The 1 was on the dash, it goes where the 4 was. That's a single switch. Do not stop after a single switch. You'll have the wrong answer. A double switch means switch 2 with 3 as well, and you are finished with your double switch. Notice you do not have to draw the molecule again, just double switch the numbers. If you connect 1 to 2 to 3 in this molecule, you clearly get, oh, forget the 4. It's not about the 4. It's about the 1, the 2, and the 3. It is an S stereocenter. The ring size is 10. It's a cyclodecane. We have two ways of numbering it, and we get identical group numbers going both ways. We could make this carbon 1 and then this 4, or we could make this 1 and this 4. We'd get groups 1, 1, 4, 4 either way. This is a rule I never enforce. I will accept either numbering scheme. So I could have made the 1 a 4 instead, and you get full credit on my test. Don't tell the people at UPAC, they have another rule to break that tie. 2 iodines on number 1. Iodide goes before isobutyl. Iodide goes before iodo-propyl. S goes in front for the stereocenter. 1, 1, diiodo. 4 dash, 4 dash, parentheses, 1 dash, iodo, propyl. 4 isobutyl. Alphabetically, iodo with nothing goes before iodo with a P, goes before iso. Ring size 10, cyclodecane. For good form, you italicize the S. I'm going to copy the tetrahedron again here. I'm going to erase the groups. It's not the groups that are important, it's their numbers. A C with bonds to 3 bromines is going to beat an unbranched C that goes 5 times, which will be beating an unbranched C which goes 5 times to a methyl. I'll explain that better in a second. That's a 2 because it's a CH2 that hits a branched C immediately. This is a 3. Unbranched 5 C's in a row to a branched C. This is 4. Unbranched C, 5 in a row, which goes to a CH3. The CH3 loses to the branched C here, the CH2. What's the first part about why do we have to do a double switch? The number 4 group is not on a dash. You need to switch it with the group that is on the dash. This time it's a 2 group. Didn't get the circle. I'm not going to panic. 3 has to switch with 1. You must do 2 switches to get the right answer. This one looks clockwise to me. One, two, three. That's R. Not S, but R. Name of this molecule, we have to think a little bit. 5, 6, 7, 8 with a V on the end. Isooctyl. Or is it? I don't believe so. The longest chain would be including both of those CH2,5 functionalities. Right there's 5 carbons in a row. 5 more carbons in a row, that's 10 with an 11th here, and whatever's on the ends here adding to that. You cannot get to higher than 11 using this as the starting. Okay, so I psyched you a little bit with that isooctyl. This is carbon 1 of the chain here. One of those CH3s goes to a CH, which has a methyl off of it. That's your first group on carbon number 2. So, without following my steps of crossing out my parentheses, one of those is 1, the other's a methyl off of carbon 2. 1, 2. Hold up 5 fingers and go 3, 4, 5, 6, 7. That makes this 8. Hold up 5 fingers. That makes this 9, 10, 11, 12, 13, with the methyl at the end being 14. Name. 8 has a tribromomethyl. I realize I forgot the stereocenter. We'll go back and fix that. Stereocenter is R. Italicized. 8 tribromomethyl. The group that I labeled with a circled 2 is really an isobutyl. So 8 also has an isobutyl. A 14 carbon chain is tetradecane. Emil Fischer won the second Nobel Prize in chemistry for his work on carbohydrate chemistry and other natural products. Most of his molecules had multiple stereocenters, so he came up with a short form, so we wouldn't have to draw wedges and dashes for every stereocenter. We have to learn that it is understood if it is drawn like this in the Fischer projection. The only proper way to draw it with wedges and dashes is horizontal wedges. All the bonds that are vertical are dashes. Horizontal looks like bow ties. Vertical looks like zippers. Bow ties are worn horizontally, zippers vertically. We didn't need to redraw the molecule. We can go straight from here. There are two stereocenters on this molecule. We got a red one and a blue one. Two separate problems. One, two, three, four. Chlorine is heavier than carbon. Chlorine is heavier than carbon. Which carbon with a chlorine is going to win? Carbon with a chlorine and two H's, or carbon with a chlorine and one H and a C? The C beats one of those H's above. And the hydrogen is clearly number 4. Hydrogen's not on a dash, is it? The nice thing about Fischer is you got two places to put the number 4. I don't need any of these groups, I just need the numbers. Fischer says, not Fischer, double switch says you can put the 4 on the top or the bottom. You're going to get the same answer both ways. You have to believe me. If you don't, try it. That switched 4 with 3 to get the 4 on the dash. You also must switch 1 with 2 to get the right answer, not the wrong answer. It seems like those guys are not associated with each other. I'm having a little trouble. Clearly not associated with each other. There we go. Lost track. I have to also switch 1 with 2. That means the 2 ends up where the 1 was. 1 ends up where the 2 was. We're not talking about the blue stereocenter. Let's get rid of it. Connecting 1 to 2 to 3 is counterclockwise. Clearly S. Making this S. One, two, three, four. Chlorine is 1. Carbon with a chlorine is 2. Methyl is 3. Hydrogen is 4. Why are we not allowed to connect 1 to 2 to 3? It's because the number 4 group's on a wedge. It's horizontal. Do your double switch again. Copy your tetrahedron, erase extraneous matters. You want to put 4 on the bottom this time? That's also a dash. need the H here, really. I don't need the CL. You need to switch 1 with 2 as well. There's your double switch. This also being S. S is 1 out on this page. A little work on my arrows here. Anyway, I think you get my meaning here. 1 to 2 to 3, S again. Means it was S over here. So there you have it. The double switch method works when the number 4 group is not already on a dash. Use it.